Environmental DNA is DNA which is released by animals and plants into the environment through processes like shedding skin and scales and fur, excretion. What we're talking about is terrestrial animals, and we are taking their DNA from the air.
So one of the ways that we've collected the material is using this modified design that we can use for specific species at risk monitoring. It's just a small fan, normally the kind that you use to cool 3D printers or computers. You pull air through here, it's a very teeny tiny vacuum, and the DNA is being caught on the filter surface, and the air just gets pushed out the other side. We designed them for the purposes of field work, where you could take them into the middle of the jungle or the forest or wherever you happen to be and be able to run them and fix them and power them.
We were careful to build up our experimentation step by step. So our very first test that we did was on a single animal species, and the next validation step that we did was in a semi-natural environment. So we actually Beth went to Hamerton Zoo in the UK, and she set up 72 filters. And from there, she was able to detect 25 different species of animals from their DNA in the air. But also what was lovely about that experiment was our first hints that we could detect animals that were living in the wider environment, so in the countryside around the zoo. Cows, sheep, chickens, things like domestic animals, but we also found UK wildlife like the European hedgehog, which is a species at risk.
I work with bats quite a lot, and bats are often the target of at-risk species monitoring programs because of rapid declines in many countries. So we went to hollow trees and artificial and natural cave systems where we had done surveys. We had a pretty good idea which species lived there, but it was now a real, properly wild environment. We sampled there. And for the most part, what we found was exactly what we thought would be there from previous work using cameras and nets and visual surveys. And to our surprise, we actually found a species we'd never seen before but had predicted would be present. So there's a common problem with all techniques that we use is that it's very difficult to make them scale. And we don't really seem to have any approach or any existing infrastructure to achieve that level of scale that we need for national biomonitoring to get a really good idea of how planetary biodiversity is actually changing.
You really need networks which are countrywide or continent-wide, but there are already these networks in place which are sampling the air. We received these filters from the air pollution networks in the UK, and we extracted the DNA which are on these filters. And from there we were actually able to retrieve over 180 species of animals and plants just from these two stations.
Each individual sample is going to be a snapshot of what might be there at a given time. But because they're being taken every day and every week in the same way, you can stack them together, the information, to get an idea of the biodiversity of a location. And that's the sort of data that biodiversity science really has not had before. One of the priorities of many international agreements is to try and monitor biodiversity at national scales. These networks represent a pre-existing nationally and internationally distributed infrastructure which may be doing this as a byproduct of their regular operation. And that's what's truly exciting about this, is that the infrastructure may already exist for national level biodiversity monitoring.